So we now move on to chapter 4. So we are going to talk about the AASHO road tests that we spoke about before, because these are the mother of all tests. So yeah, so the AASHO road tests was a $27 million project investment, and was the largest road experiment of its time. It was conceived and sponsored by the American Association of State Highways officials, which where it comes from, that the AASHO comes from, as a study of the performance of the highway pavement. I'm sorry guys, if but I'll try and explain all abbreviations. Sometimes, like I know I started just saying AASHO, but this is what AASHO means. Like I knew that we were going to get to it when we're actually at the topic, so this is what AASHO means. So please just try and remember this, or you can always come back to the slide if you get what AASHO means. So as a study of the performance of the highway pavement structure, of known thickness under moving loads, and of known magnitude and frequency. So this is from the Highway Research Board. I think I referenced this in the reference section. The test studies both Portland cement concrete, so that's PCC. So whenever you see abbreviation PCC, it means Portland cement concrete, and asphaltic concrete pavements, as well as certain types of short span bridges. So we already touched on all of this. The information obtained from the AASHO guide was crucial in advancing the knowledge of pavement structural design and pavement performance and loading equivalences, climate effect, and much more. Which is why I'm saying this is the mother of all tests. This is the mother of pavement design. This is where it all kicked off and became very scientific and became official, and it became something that was recognized on the world stage. So hats off to the guys in the United States of America. They did well in terms of engineering. They did very good for us who are now using these methods, and we don't have to struggle, and we didn't have to go through all this. Yeah. So the basic performance information resulted in performance equation and monograms used in the AASHO guide, the AASHO 1993 guide. This section provides some background information, of course, on the AASHO road test, so that you can understand why these tests are important, and it should be helpful in understanding the experiment strength and the weaknesses and the limitations. So every time when you're designing as an engineer, like remember, there's risk, so you need to know the weaknesses and the limitations of your design, and your client must know the limitations of your design so that you don't overpromise and fail to deliver. So it's very important. So let's move on. Okay, so that's the background. So this section, this section of section 4 provides some of the basic background for the AASHO road test, and is taken primarily from the Highway Research Board Special Report 61A. It's online. You can just Google it and you'll find it. The AASHO road test history and description of the project in 1916. Okay, so the location is Ottawa in Illinois. So the AASHO road test site, which eventually became part of the I-8 in America, I think it's a highway, at Ottawa, Illinois, was typically of the northern climate. So you can see these are, so the temperatures are 24 degrees or 76 Fahrenheit, so it's warm. Average mean temperature in January is -2, so it actually gets cold. I think it snows. I'm not sure how the American climate. I've never been to America. The annual average rainfall, that's a lot of rainfall. And that's the daily depth of frost. That's also a lot of frost. So it's typical USA climate. So it gets hot, but it's not that hot because it's only 24.5 degrees. Like in Africa, the temperatures go up to 40, 42. So this is really not that hot, and it actually gets really cold. Like that's terribly cold. But we experienced snow in South Africa this year because climate change, but that's a story for another day. But yeah, and it rains. Yeah, it rains a lot. It's 34 inches of rain. That's a lot. So yeah, so this is just the background of the. So this is where this is an empirical method, but they also considered climate and rain, all the climatic aspects or the climatic factors. So this is what I'm trying to touch it. So this is the background on how they got to those equations. So this is the breakdown of how the test was done. So in terms of time, it was constructed in August 1956 to September 1958. The test traffic, it underwent test traffic from October 1958 to November 1960. Then the specialist study was done in spring and early summer of 1961. So the test facilities had 6 two-lane test loops, as you can see in figure number 5. So test loop 1 was not subjected to traffic and was used to test the environmental effects, so it was like the control. Then loop number 2 to 6 was subjected to the traffic load, so this is the one that they were using to see how the traffic will affect the road pavement. Anyhow, so this is a picture of the loop, of the two loops, of one of the two loops. So there you, this is just a typical of the loops. So now you can see exactly what it looked like. So as you can see here in figure 6, these are the weights that they were using. So front axle, load axle, gross weight. So the weight is in kips. So you can just convert that to kgs if you like, or you can convert it because it's empirical. You can convert it to metric or whatever metric unit you want to use. So this is a different load, different loads. You can see the different types of trucks they were using with different tractor trailers. So this is just to try and give you guys an idea, like to be able to visualize what they were actually doing. I think that's all for that. So let's move on. So then we move on to the performance measurements. So the following measurements of performance were collected. So obviously roughness and visual distress for both hot mixed asphalt and Portland concrete cement, and then obviously diffraction and strain, and obviously the pavement serviceability index, the PSI. So then we now move on to the hot mix asphalt pavement materials. Information for this section has been taken from the Highway Research Board from 1962 and the Highway Research Board 1962B. So I'm referencing where I got this information. That's not my own. So it's important so that, you know, to avoid plagiarism, you know, as an engineer, I must always follow our ethics, because, you know, I'm held to a standard by the Engineering Council of South Africa and New Zealand engineers. So I'll always reference where I got the information from. So the primary material used in the HMA pavement section will be briefly described below. I'll do that. And the kind of information is helpful when comparing the particular project sets, materials to those used in the road test. So the HMA mixes used at the road test are crushed limestone and coarse aggregate, natural silicose coarse sand, mineral filter, which was limestone dust, penetration grade asphalt, cement 85 to 100 pen. The graduation requirements for the surface and the binder courses are given in figure number 7. So let's go to figure number 7 and let's have a look at that. So as you can see here, these are the graduation. So this is the sieve size. So these sieve sizes are in inches. You can always convert them to millimeters because we use millimeters for our sieve sizes. And then you can see the binder course. So you can see the percentage, the different percentage passing, also the graduation limits. So you can see the different percentage passing. I won't touch into this. This is basic geotechnical engineering. So you guys should know how to do this. For the HMA surface test section in loop 3 to 6, the surface course was 1.5 inches thick. You can convert that to 2 centimeters. The HA mixes were designed by Marshall method using 50 blows per phase. The typical filled asphalt contents were about 5.4 to 4.4% by weight of the total mix of surface and binder course respectively. The filled air voids averaged 77.7% for the 6 test loops. Okay, so we're done talking about all the materials that we use. If you are familiar with all of this, go read it up, go look it up, and then come back. Go read up on how we mix asphalt or how we carry out the mix designed for hot mix asphalt. I can't go into that. That's a whole nother course in itself. So please just go read up on it. If you guys really want to know about it, just put in the comments and I can make a course for it separately. So without any further ado, let's move on. So for the base course, the material was crushed dolomite limestone that conformed to the graduation range as shown, as you can see there below. So it's significant to know that 10% passed at the 0.05 millimeter, you know, that number 200 sieve. Thus the base was likely to be a bit frost susceptible because like that was very thin. That's very fine material. The California bearing ratio of the base material averaged 107.7% based on the laboratory tests. However, the test results should range from low 52% to high 160%. So, and a total of 11 tests were carried out. The minimum specified CBR was 75%. So typically in place mean dry densities were about 2242 and 2275 kgs per cubic meter. So that's like 140 to 142 pounds per square feet per cube feet, which means moisture content was ranging between 5.6 to 6.1. So all of this is basic geotechnical testing. If you guys are not familiar with your geotech, you need to go read up on that, or you need to be looking at that. I'm currently studying geotechnical engineering, so I'm familiar with most of this. We've been doing it in school, we've been doing our labs, and also I did it obviously for my undergrad. So if you're not familiar with this, most definitely go read up on how to find your dry density so that it makes sense as we carry on with the course. So for the subbase, the material was sandy gravel. So the mixture was conformed to the following graduation. So you can see this is the graduation. So you can see this is a specific range passing, the percentage passing, and then you can see the sieve sizes. So this we don't need to touch on this. You can just look at this, and then we can move on. Or I'll give you a few seconds to look at it and internalize what I'm trying to get across. Okay, without any further ado, let's move on to the next slide.